Let's start today's lecture. So a quick recap, since it has been a while since we last had the lecture a week ago. So what we talked about last week was we got started with BDD, talking about behavior-driven design. And we did part one. I watched a couple of videos. I added some more comments on that. And then we had a quick walkthrough about the practice setup. Not sure if you guys had any chance within this week to do the practice or just play with it for a bit. But anyways, hopefully you get the chance to catch up on the progress or the homeworks. But regardless, this week, so we're basically finishing up the second part of behavior-driven design. So we will watch the remaining videos today. We stopped we were watching one of the videos and then we stopped in the middle of that. So today we will pick up from there. I have a few more comments on the videos once we finish that. And then if we have got extra time, we will then have the time for you guys to do the practice. If you already finished it, then let me know. We can arrange something else for practice for today. But that's what we're looking at for today's lecture. So now let's get back on to the video.
We'll find.
Okay, pause a bit here. So we ended our last lecture around here, I believe, if I remember correctly. So the professor was talking about the pivotal tracker platform. I think it has like a free trial or something. So if you want to try it, definitely go ahead. And then there are actually other similar platforms or tools available that deal with basically the pivot planning to manage the to-do list, manage what's ongoing, manage what's in the backlog. It's basically what it's doing with it. For example, in our team, we use Trello for project management or task management. It's a similar thing. So you could definitely just use that platform, the Pivotal Tracker platform, but also feel free to use any other task management or project management platforms. The idea is similar. But that's basically we ended here. The professor was showing this platform and its functionality. But the idea is that in this video, we want to learn how we typically manage tasks, and do the scheduling. How do we do scheduling? How do we prioritize the tasks, and how do we monitor our progress, and how to make better estimation. So we'll continue this video on that topic.
Its way into the current iteration column after you've clicked the Start button. And in a moment, we'll go through what the different values, accept, reject, finish, what do all these different things mean? Because in terms of the way you run your project, they have very specific meanings. Okay, so that's an overview of what it looks like. Let's talk about what it does for you, I suppose. Rather than walking you through everything about the tool, I think I just gave you the basic idea of what it's supposed to do. They have an awesome website where, depending on how you prefer to learn, you can either read 5 short articles or you can watch 5 short screencasts where they basically show you how to use the tool. And you'll see that they use a lot of the terminology that we have been using. They talk about stories, they talk about points, estimating complexity, they talk about velocity. One of the key concepts they don't necessarily talk about as much, but we will implement for your teams, is that for each iteration, there will be a designated person on the team who is the voice of the customer. So if you're in the team meeting, you need to make a decision, the customer is not in the room with you, there's someone whose job it is to basically try to behave the way the customer would have behaved. And we'll try to arrange it so that you get to rotate that role and different people have a chance to do it. Like I said, this aspect of dealing with stories in the planning phase is actually really important. So you absolutely should expect questions on the exam and stuff like that about the story lifecycle. So now that you're paying attention, let's talk about the story lifecycle and what those categories mean. So like we said, the icebox, stories that you know you have to do, but they have not yet been prioritized, they haven't been started, they haven't been assigned to anybody. The backlog, which is stories that haven't been started yet, but you have gone through the exercise of estimating the difficulty, and in conjunction with either the customer or the product owner, you have prioritized which ones are the most important. Those are the ones that you're agreeing to work on next. And the current iteration, which is the stories that are in progress. Somebody is right now developing code and tests to make that story happen, which implies that depending on whether you're doing single or pair programming, only one story should be in progress by any developer or by any pair at a time, right? Now, does that mean that there will never, ever, ever be a case where a pair is working on, 2 stories instead of 1? No, sometimes it could happen. For example, sometimes you find you begin to work on one story, but what you didn't realize before is that that story actually depends on some other story, and you can't make progress on the first one until something is done about the second one. So in that case, you can either have 2 stories that are both started, or if you want to sort of be squeaky clean and really follow chapter and verse, you can change the first story back from started to not started, because you can change the story state to either go forward in time or backward in time. Then you can start the story that it depends on, and when that story is finished, now you can restart the one that you began originally. So it might happen that you'll have more than one story open, but in general, you'll find that your code base is easier to manage and your work is easier to track if you try to keep the rule of thumb, remembering that in a team of 6, if there are 3 pairs, that means there are 3 stories open at any given time. That means you're going to have 3 different pieces of work that have to be cleanly merged into the master. So when you're working on something just by yourself, having multiple things open is not a big deal. But when there's a whole bunch of other people on your team and everybody is working on stuff, the more total stories are open, that's going to be like the square of that is the pain of trying to merge stuff, right? And the likelihood that you'll have a merge conflict and want to throw something at somebody. Was there a question here?
So on the previous example you showed of your thing, there were a lot of stories in the current category.
Yeah. So
were they completed, or were some of them dependent on others, or how come there could only be 1 in progress but you had lots?
I had like 3 or 4 in progress, right? So, can I come back to that? Part of the answer is that right now I'm the only one on that project. So if I have like 4 stories in progress, it probably means I've got 4 different branches, and at some point I'm going to have to merge them. But the 4 stories are in different parts of the code, and I'm the only guy right now. So it's okay. It's really, what this rule is about is preventing things from happening in the team that other people don't know about. If you've got 4 different pairs all working on 3 different stories per pair, there are sort of 12 things happening in the team, and it's going to be hard for the rest of the team to sort of keep tabs on that. So the fewer people are involved, the more you can relax this. But there's also another part of the answer, which I'll get to in a moment, and it has to do with what the different states of a story are when they're in progress. So the story life cycle. And I have conveniently color-coded it with apologies to people who have visual issues with colors, but I tried to pick ones that are representative. Stories in the icebox, they've just been created. And the next thing that's going to happen is you're going to estimate points. That's what's happening in your planning meeting, like planning poker. That moves a story into the backlog. And in the backlog, stories have been prioritized, and then they get assigned to a developer or to a pair. Once the pair picks up a story and begins it, that moves it into the current iteration, and it's in the started state. They will continue to develop code and tests until they declare the story to be finished. Once the story is finished, it is delivered. That means it is deployed in some version of the product the customer can see, or at least that the product owner can see. Sometimes the customer may not have time right away, but at least the product owner who speaks for the customer, in the delivered state, the product owner should be able to actually exercise the story, and it should work. And when the customer finally sees it and customer tries out the functionality, they say, yep, this is what I asked for, I sign off on it, then and only then does it become accepted. Okay, so this last step is the critical one because the team doesn't get to say when the story is accepted. The customer says when the story is accepted. So what does this mean in terms of the story lifecycle? What's happening at all these stages? The stories are created. That comes out of your meeting with the customer. The stories are estimated. This is where you have a team meeting, and coming out of that meeting, at least a subset of those stories have had their difficulty estimated through the planning poker process. Then they get prioritized, they get assigned to people. Once a story is started, that means people are working on code and tests for that story. When we talk about how to keep your team's work nicely coordinated, we will recommend that you use a methodology called branch per feature, where you make a new branch in your GitHub repo, and that branch is only for the purpose of doing that one story. As soon as the story is closed out, the branch is incinerated. Okay, so we'll talk about branch per feature a little bit later. When a story is finished, that has a specific meaning. It means that there are code and tests that are checked into the repo on that branch, and if anybody in the team was to go into that branch, they would be able to run those tests and the code would actually work. Right? So finished means not just the code, but the tests that cover that code are in place and should be expected to be passing. We will show that there are ways you can automate this using continuous integration so that anytime you push a branch, you can immediately tell if you broke something if you have decent tests. Delivered has a specific meaning. It means that it is deployed somewhere that the customer can see it. Probably in your case, it'll be deployed on Heroku in like a staging environment. And then when the customer or the product owner, if the customer is not available, actually inspects and interacts with the deployed feature and agrees that it matches what was said in the customer meeting, then the story becomes accepted. That's when the story is finished and not before. And finally, estimating velocity is at the end of every iteration, how many stories have gone from step 1 created through step 7 accepted. The number of points of all of those stories is basically your instantaneous velocity for that iteration. And Tracker automatically calculates that and also sort of smooths out the average over 3 or 4 iterations of the project. Who does each of these things? The story creation phase, well, that should be everyone because you should all be present at the customer meeting when you're discussing what you're going to work on next. Similarly, you should all be at the team meeting where you're doing the estimation. The product owner really sort of gets to break ties on prioritization because remember, their job is to sort of keep track of what the customer said was most important, what they said they wanted, and make sure that that is reflected when the stories are prioritized. Assignment, it could be the product owner, but again, this is a case where if there are particular people on the team, let's say, who have expertise in certain technology, and there's a story that really would benefit from that, it makes sense to have that pair or that person work on that story. So teams can usually sort of self-regulate, but in the worst case, the product owner can break ties. A story is started, so whoever owns the story, there's always a story owner. You can also assign a pair of owners. And then the product owner, or the customer ideally, is the one who gets to say accepted, and the tracker tool itself is what estimates your velocity. Okay, so it's a simple, but it's a surprisingly eye-opening way of tracking how much code is actually sort of in flight, which is stuff you've started, and maybe you've kind of finished, but you haven't really tried it in live mode yet, or maybe it's live, but you haven't gotten final sign-off. We have found Tracker to be super, super useful for doing all of that stuff. Everything that you're seeing in terms of how I use Tracker, you can set up a free account, and you can set up a test project to use it. For the course projects, we will set up a tracker for you, because I have an academic account with superpowers where I can have like infinite number of projects, and every project can have infinite people. And you can't do that with the free account. And that means that the GSIs and I will have visibility into your tracker as it should be so that we can sort of keep tabs on whether teams are really using the tool effectively. And hopefully that will help them turn out better code. Because there are a lot of ways to misuse Pivotal Tracker and this process. One of them I already mentioned on Tuesday, which is the temptation to divide up the work by layers. So instead of saying the story is to deliver this functionality end to end, you tend to break it up as, OK, one story is do the front-end pages and JavaScript. A different story is do the server-side part. Another story is writing the tests. Don't do that. Right? A story is, even if it means that the amount of stuff in the story is small, the story tends to touch every layer, and that works to your benefit. Bugs. A bug is a story, but it's not. It is a story in the sense that it has a life cycle. And we'll talk more systematically about what a disciplined bug life cycle should be. But if someone discovers a bug and it's reproducible, so it's a bona fide bug, then that bug has to go through basically the same process as a story, right? Someone has to be assigned to work on it. It has to be prioritized. Is this like a killer bug that is going to screw up the app for the customer, or is it a rare case, and maybe it's not as high priority right now. Someone has to write the code has to be tested, it has to be merged. The only real difference between handling a bug and handling a feature in Pivotal Tracker is that if you designate something as a bug, it gets 0 points. Because the idea is you shouldn't be counting time spent fixing bugs as time that counts toward velocity, because velocity is basically how much business value did you deliver to the customer this iteration. Now, you could argue fixing a bug is business value, because if you didn't fix the bug, the app wouldn't work. But the 0 points convention is to basically say the business value was in the feature in the first place. If the feature is worth 4 points of business value, and you think you delivered the feature, but it turns out there was a bug, you haven't actually delivered 4 points of business value, right? You're sort of not finished yet. So that's the reason that we encourage the use of Tracker where bugs don't get points. Because it really kind of encourages you to think in advance about, have you covered as many cases as you can? But other than that, they need to be tracked. They have a life cycle just like stories do. Using Tracker as a to-do list. This is probably the most common misuse of Tracker, where rather than sort of really being disciplined about this process, you tend to say, oh, right, we just sort of checked in the code that does all that, and we deployed it, and the customer liked it. So you end up having a story that doesn't really exist. You quickly create it, then you move it to the icebox, then you move it to the backlog, then you move it to current, and then you mark it as done. Basically, all you did was make a to-do list that has 4 steps for doing a to-do item. That's not useful, because every time a story does something in Tracker, if it moves from one category to another, if it gets started, finished, Tracker records when each of those things happens. And part of the goal of using the tool is over time, you will get better at estimating your own team's ability to complete stories. And how complex are they really, and how likely is it that they'll result in bugs you have to clean up afterward. But if you just use it as a to-do list, if you don't actually follow the process of saying, OK, before a single line of code is written, has the story been prioritized? Has it been assigned points? Do we know who's working on it? Has a branch been created? If you don't follow the process, then Tracker can't really help you, right? It's designed to help you get better at this, and this is a really, really useful skill, and it is very hard. I've been doing this for years, and I'm still working on my ability when I say, that's a 1-point story, which to me, I use 1 point as meaning I can sort of knock it out in about half a day's worth of work. And for me, a 2-point story is if I have a whole day uninterrupted, I could knock out a 2-point story in that day. And I'm right, like maybe 2/3 of the time, maybe 3/4 of the time. I'm not right all the time, and I have done this quite a bit. So it is really worth your while to try using the tool the way it was intended to be used, because we think that that will help you get better at doing this more quickly. And we've actually got other monitoring that we're going to be deploying that will basically tell you whether it thinks you're using Tracker correctly. So it is a tool to track how you use the tracking tool. How's that for meta? And that's basically it for Pivotal Tracker. Like I said, there's these tutorial videos. They're not hard to do. We encourage you to play around with the free account. We will create accounts for you that have all the necessary features for doing the projects. A lot of the projects, because we're picking up from previous projects, already have a Pivotal Tracker. So you're going to actually see some stories that the teams before you who were working on that project got to complete.
OK. So that's that about Pivotal Tracker. So you probably would have noticed that one of the main value proposition, or one of the feature the Pivotal Tracker offers compared to other task management, is it actually helps you to estimate velocity, meaning instead of estimating how long each task would take, you simply just estimate the points, and then the Pivotal Tracker system will actually run the average and then calculate what's your the average of time you spent on each point of task, which makes sense. It actually should help the team make better estimates. But realistically, sometimes we just don't do that. It's simply because it's a bit more stuff to do, a bit more overhead, and also typically for someone like the stakeholder or product owner won't be available even to look at this kind of information or estimates. What they mostly just want is the straightforward estimate for the time, not points. But anyway, it's still something good to check it out, and I think at some points, although most of the ministries don't have a big team, but at some point maybe we'll have a big enough team, then something like this will start to make sense. All right, we'll get to the next video.
Isn't that the cutest thing ever? If you go to the SF Zoo, you can actually see one. That is the world's largest aquatic rodent. It's a capybara. And ask me sometime if you're interested in why one of the tools we're about to introduce is called capybara. So we're going to introduce cucumber and capybara, which I think are probably, if I had to pick one tool or technology in this course that is sort of the coolest single one, if I had to put all the others aside, this is the one that I would pick to keep. So what's the big idea behind cucumber? If you believe that these sort of 3x5 index cards plus mockups, user stories, are a reasonable way to come to agreement with the customer, because you can describe in plain language what the feature is supposed to do, you can draw simple pictures about it, then you can actually get two different kinds of tests out of that information. One of them is just testing whether the code you wrote for the story functions correctly. And the other one is one that essentially simulates what the customer themselves would do if they were using the feature. And sort of by definition, if you kind of went through a storyboard mockup saying, OK, if you click here, you see this, and then if you fill this in, you should see this. If you can do that process, but automate it and capture it in a test, and that test passes, then by definition, the thing you step through with the customer behaves the way the app does. So it's an acceptance test in some sense, as well as an integration test. What I love about Cucumber is that it kind of bridges this gap between the customer and the developer. The thing about a user story is because the user story itself is not code, you can't use the story as a test. But if you could convert the story somehow into code, and that were the test, then the story would actually give you some satisfaction that you're doing the right thing and doing the thing right. So Cucumber essentially lets you rewrite your user stories in a language that is somewhat restrained. It's not like totally freeform, but in some sense it is much closer to English, or for those of you in TV land who program in another language, it is much closer to a spoken human language than it is to a programming language. Cucumber scenarios look a lot more like prose than they do like code, which is one of the reasons they are so useful on both sides. So let us show one. And I'm going to, before I show you an example scenario, I'm going to give you a disclaimer. The scenario that I'm about to show you as an example is valid. It works. I will demonstrate live coding, like I'll run it and show you that it works. And then I will tell you that you should not write scenarios the way that this one is written. But for the moment, let's use it as training wheels. Here's an example user story. And like we said on Tuesday, an example of a simple feature for our Rotten Potatoes movie database is the user can manually add a movie. Right? So that's the feature, the general functionality that we want. Here is one scenario that would illustrate that feature in progress. So this is actually a list of steps that it's almost like a script, right, that a human being could follow if they were using the app. And if they follow this set of steps and they step through all of the screens, then this is what should actually happen. So here's my simple Rotten Potatoes app, which you've all seen before. I'm going to compress the window here so that we can see both the window and in the top half of my editor. Okay, so on the top half of my editor on the right, that's the exact set of steps that was on the slide. So if I follow it like a script, right, given I'm on the home page, which I am, when I follow the link for add new movie, so if I scroll there, there's the link, I follow it, then I should be on the create new movie page. Look at that, indeed I am. if I fill in the title with Men in Black, and I fill in the rating as this, and I press Save Changes, then I should be back on the home page, which I am, and I should see Men in Black somewhere on the list, and there indeed I do. Okay, so it's quite literally, this format is a script that describes what the human being interacting with the app would do if they were exercising the feature manually. And by the way, just to prove that I have nothing up my sleeves, the file that I was just showing, this one is called addmovie.feature. And if I actually run that, which I'll show you in a minute how it works, I always start with bundle exec, as we've said so many times. Green, 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 green. Every green line is my test actually interacting with the real app through the same mechanism as a browser would. It is basically, from the app's point of view, indistinguishable from a real human with a real browser, except that, of course, it works much faster than a human would. So for the rest of today, what we're going to focus on is what's going on there, what makes it happen, and why is it cool. What I just showed is an example of a feature. A feature is the kind of thing that would come out of a customer meeting, such as, I would like to be able to have it so you can manually add a movie resource to the database. The feature will turn into some number of scenarios where each scenario is basically an example of the kind of thing I just showed. A list of steps that somebody would follow that in some way exercises part of that feature. Now, the version that I just showed is kind of the most straightforward thing you can imagine. That's the version where I do everything right. I don't try to type in a movie name that has illegal characters in it. I don't accidentally hit the delete button instead of hitting the save button. So things that, if everything goes exactly according to plan, and with real users it rarely does, then I proved that version of the story works. For reasons that should be obvious, but we'll talk more about in a minute, we call that the happy path story. Scenarios, typically some handful of steps. Why would a scenario not be a much larger number of steps? If you had a scenario that had 20 or 30 steps in it, what does that imply about the user story that the scenario is based on?
It's not specific enough.
It might not be specific enough, or even simpler than that, it might just be too big, right? Small stories are good stories. You can always take a big story and break it down into nice pieces that are individually testable, but if it really takes a sequence of like 20 or 30 interactions to express the story, that story is probably already too big. The part we haven't seen yet is what are called the step definitions. So for every line in that story, given I'm on this page, when I fill in this, each one of those lines somehow needs to be turned into the actual code that makes those things happen in the app, that stimulates the app externally to make it react the same way as if a human was doing it. So we'll talk about step definitions in a moment, but just a little bit more on what the steps look like, the individual steps in the script. In general, there are sort of 3 kinds of steps, but 5 keywords that talk about them. There are steps that begin with given. They talk about what the state of the world is assumed to be before the story happens. So maybe the story involves sorting the movies according to some order. Then clearly, one thing you would need to specify before is, OK, well, which movies already exist? Because then we can talk about what it would mean to sort them correctly. So what is the state of the world prior to the thing that I'm trying to test? When steps are the actual thing that I'm trying to test. The user does something, and the effect of the user doing something is what's exercising the functionality of the story. Finally, there's then steps, which is after the user has done something, some other condition should be true as a result of that action. Something has changed, for instance, or something is displayed. So the then steps are typically checking if the post conditions are true. And you may also see keywords and but. So then I should see this on the page, but I should not see that on the page. Or then I should see this on the page, and I should see this on the page as well. Okay? What's interesting is that in the actual user story, these are all aliases for the same method. So to make that concrete, if I went back to my example story here, and this is actually, if you remember, this was the contents of the actual Cucumber file, which we're going to explore in more detail in just a moment. If I changed every beginning of line word here to the word given, it would not affect the way the story behaves. If I changed everyone to the word then, or to the word but, or if I just randomly chose the words given, then, when, etc., and I randomly picked which one should begin every line, it would not change the behavior of running the test. So my question is, and it's not a clicker question, why bother? If it's all the same in terms of how the test runs, why are there different keywords for different types of steps? Because clearly, they aren't really different types of steps if the keyword doesn't make any difference. So why? Yes?
So the user, the person testing, understands.
Yes, so the user, and by the way, in this case, user is not just necessarily the customer, it's also you. So that you, when you're reading this story, can actually mentally keep clear which steps are things that I'm going to assume to be true, which steps are actually exercising the app, which steps are checking if the post conditions are correct. In fact, if you write your scenarios well, which in a moment we'll talk about what a good scenario is, the scenarios become documentation. I actually, just a couple of weeks ago, I was dealing with one of my own customers that uses the app that I showed you a tracker for. And they had an obscure question about some feature that it had been like a year since I looked at the code for that feature. I actually didn't remember how the feature was supposed to work. But I had some really good scenarios that basically said, given the customer starts from this state and does these things, here's what should happen. That was documentation. That allowed me to remember, right, now I remember what they wanted that feature for originally, and now I can verify what the feature is supposed to do. Now I can go answer their question. So scenarios are super valuable. And this is the other reason we've had students ask, and for a while there was a sort of internet war going on about, as we'll see, Cucumber itself is really just kind of a front end. It lets you write these nice stylized things, but in the end, you need actual code to make the test go. So for a while, there was a question of, well, if you need code to make the test go, why not just have that be the test? What is the value of having this sort of layer of sort of cutesy-looking English sentences over it? That's the value. It's documentation. The customer can read it. It's not technical. And as the developer, it reminds you of what you were thinking. So those are the 5-step keywords, all aliases for the same method. And now let me ask my first question. Again, not a clicker question, just a let's think about it question. I showed you an example of the story of adding a new movie manually. And I'm now asking, why is that scenario that I just showed you insufficient by itself to claim that we have tested the user story about the user manually adding a movie? What are some things that we really need to be doing if we want to claim to have a test for this, but that we have not done using that simple scenario that I showed you? What could go wrong? Yes? Only includes the happy path, right? That's one thing, is that I've not checked what happens if the user, for example, tries to leave the movie field blank. That would arguably be something you'd want to prevent. So there are various ways the user could misuse or accidentally screw this up, and I have said nothing about how we test those. What else? And just as a reminder, I'll put the story back up. After I have filled in stuff, and let's assume that we filled in legal things, we save changes, then I should be back on the home page, which is the page that lists all the movies, and I should see the name of the movie. Anything else missing? Anything else I should see? Say again? I should see the other movies, that's true. Let's assume we have a test somewhere that I didn't blow away the other movies, but what else? I mean, I filled in a title and I filled in a rating. Where am I checking that the title and rating I filled in actually were correctly saved? Right? I'm actually, in this example, I'm actually not. So in fact, not only does it only check the happy path without checking the sad paths, it also doesn't really fully check the happy path. The only thing that says in the test is I see the name of the movie back on the home page. And yes, that is certainly important. But if this was a real test, I probably would also want to check that the title and rating information are consistent with what I put in, not just the title, but also the rating information. So it doesn't even do that. Pretty weak for a test. And it doesn't check the sad paths at all. So we'll talk about how to resolve those things. But the moral of the story is that typically, one user story becomes various Cucumber features. What the customer thinks of as, oh yeah, let's be able to add a movie manually, that's going to turn into quite a bit of testing. And I'm going to elaborate using a feature that I developed last year for my app, which is the ubiquitous, if I forget my password, is there some way that I can log back in? I happen to hate the secret question approach because I don't remember like what my favorite color was in 3rd grade, but whatever. That's what they wanted, so that's what I did. So the feature from the customer's point of view is, could you do the thing where if you forget your password, it lets you answer your security question? And from the customer's point of view, that's legitimate, right? They've probably used a lot of sites that have that. So from their point of view, they probably think they're being pretty specific about what they want. For me, I was able to turn this into a handful of scenarios, like if the customer answers their secret question correctly, it logs them in. If they answer it incorrectly, it doesn't log them in. If they have never chosen a secret question with an answer, then they can't use this mechanism to log in, right? The explicit thing, use a secret question for login recovery, that came from the customer. The customer never said these things, but these are implicit. They logically follow. If the customer wants that, then these are some cases we have to consider. And in fact, even here, we haven't gone far enough because this just talks about if they have or don't have a secret question, then maybe these are the scenarios. But we haven't even talked about how they could get a secret question. So there's that. That has to become, oh, by the way, happy path, sad paths, right? So we haven't even talked about what happens to set up that secret question, because clearly, the happy path here and this first sad path story, they both assume that somehow the customer has set up a question and answer. So I got to do that one too. I need a separate feature, which is how do you set up a secret question? And again, that's going to break down into a handful of scenarios. The happy path is the customer can establish a secret question. Possible additional one would be if somebody has logged in and they have not set up a question yet, then they get the little reminder saying, would you like to set up a security question? And that also means that, OK, if they already have a security question, then they shouldn't see the reminder. So you get the idea, right? The only thing the customer said was, can you do the thing where the security question lets you log in if you forget your password? And that sort of leads to this tree of requirements. So the difference between the customer meeting and the team meeting is really that. You come out of the customer meeting with, I want the security question feature. The team meeting is, OK, well, that implies that we've got to do at least a couple of these different features with multiple scenarios. And this is the granularity at which you're going to do points, right? Because now you're getting from what the customer said they want to the nitty-gritty of, OK, what are the specific interactions we have to implement in order for that overall feature that the customer said to really work? OK? What questions do you have about this? Again, most of this is not rocket science, but the systematically thinking it through and going through this entire process of outlining the features and the scenarios before you write any code is a strong predictor of being able to actually deliver something good at the end of the iteration. Onward? I'm assuming we're going on. OK, so what have we not talked about? So far, we've only talked about what did the story sort of look like. And we've got these 3 kinds of steps and so forth. We have said nothing about what makes those stories become runnable in a way that actually interacts with the app, just as if the user were doing so. So that is next. And in particular, really in all kinds of steps, but in the when and then steps, what we really need is something that interacts with the app the way that a user would through something like a browser. We can say that it sort of pretends to be a user and steps through the scenario. And Capybara is that tool. Capybara is super, super awesome. And in fact, most of the heavy lifting of tests that you write with Cucumber is really done by Capybara. So Capybara is a library that provides what in the business we will call a headless browser. That means that internally it does everything a browser can do. It can make requests. It can parse HTML. It can create a data structure representing what would be on the page. It can execute JavaScript, and it can have JavaScript interact with that data structure. The only thing it doesn't do is actually pop up a big window and display the page. Although, as we'll see, you can force it to do that if you really want. So for all practical purposes, Capybara library allows you to interact with the app, kind of like what we were doing with curl, where instead of having an interactive browser, we have a command line. This is like curl on steroids. It can do all the same things with the responses as a full-blown web browser would do. And in fact, it tends to be based on the same technologies that web browsers are based on. So how do you, oh, sorry about the weird, that's That's a nice little preview. So what's the connection between the steps of the script, given, when, et cetera, and the step definitions, which is the actual code that makes things happen? This is the magic of regular expressions, which I'm sure you all know and love. And if you were just waiting for an excuse to get back on top of your regex foo, that opportunity has now arrived. If you weren't waiting for that opportunity, it still has arrived because you'll be in a world of pain without regexes. But basically, what happens is when Cucumber is running a test and it sees a line like this one, like I picked one of the lines from my simple example, I fill in title with men in black, it will look through a bunch of files in my project that contain step definitions, and it will look for some regular expression that could possibly match that. Here's an example of such a regular expression. It looks a little more complicated than it really is. In particular, don't worry about the initial question mark here. This is a fancy notation, which means that the I is optional, and if it's not there, it's fine. It won't be captured. But the important bits are these bits. So since you're all regular expression masters and mistresses, can someone remind me, when you have parentheses as part of a regular expression, what are they used for? Parens in a regular expression?
Capture group.
Capture group. Whoever said that, double thumbs up. Capture group means that if the regular expression that you're comparing the string against actually matches up, then the parts that match that happen to be between parentheses will be remembered. And in this case, we've got two sets of parentheses, so we've got two capture groups. Will this regular expression, in fact, match the string? Here's a hint. I probably wouldn't be putting it up if the answer was no. I'm not going to do it just to mislead you. But so that you remember, and I will send out the name of a website called Rubular, which is a great place to practice regular expressions in Ruby, although the syntax is basically the same in all languages that have them. This says, I'm looking for 0 or more occurrences of anything that is not a double quote. And here again, I'm also looking for 0 or more occurrences of anything that is not a double quote. So this entire regular expression matches as follows. The word when, got that? The beginning of the step, so caret anchors a regular expression to the beginning of a string, $ anchors it to the end. Believe me, you're going to see a lot of this. So don't worry if you, again, don't write all of this down. You'll absorb it by osmosis or by drinking from the fire hose. So I, optionally, yep, there's I. Fill in, fill in. Quote, quote. Any sequence of characters that is not a quote, that's the word title, followed by another quote, there it is. With, and then same deal. Open quote, any number of non-quote characters, closing quote, end of string. So two things happen here. Thing number one is those two match. It is the case that the regular expression matches against that string. The second thing that happens is the pieces that matched that were enclosed in parens are going to be assigned to two capture groups, and Cucumber arranges to make them available as arguments to a block, an anonymous procedure that is the body of the step definition of any Ruby code. If we look at the actual step definition that matches this, and we ask, what does the code do? It does this. So what was the step definition supposed to express? That there's a field on that web form called title, and I'm going to fill in as the value that a user would type into that field the string men in black. Those two get captured, and they get passed to this method called fill in, and it takes one argument, which is the name of the field, and a hash argument that is the value that the field should be filled in with. This is one of a great many super useful methods that Capybara gives you. What this means is, based on the most recent page loaded from the app, find a text field that has this name, and fill that in as if the user was typing with this value. Super, super cool. So this is what I mean when I say that the heavy lifting is really not being done by Cucumber. Cucumber gets you as far as saying, I'm going to look at the steps in your script, in your scenario, and for each one, I'm going to try to find a step definition whose regular expression matches. And when I find it, I will execute whatever the body of the definition is, and I conveniently allow you to capture things that were in the original step and pass them as arguments, basically. Right? That's the essence of what's going on here. So what kinds of things would you expect to find in the body of a step definition? Well, one kind of thing is if there are preconditions that your test depends on. For example, if I was writing a test that depends on a number of movies already being in the database, I can imagine that there would be a step definition where I'm going to make some active record calls to create those movies, because I need to make the state of the world look the way that my test expects or assumes. What else might be in there? Well, calls to capybara, and at least two types of calls. One of them is calls like this, where it simulates the user doing something. I fill in a field, I follow a link, I click on a button. The other type is one where you're not changing the page, but you're inspecting. So when we had that last step that says, then I should see so-and-so on the page, again, we can ask Capybara, look at your internal representation of the page and see if this string occurs somewhere on the page. And as you might expect, you can actually get much more specific than that. You can ask, does it occur within a particular div or within a particular element? Is it the case that a drop-down menu contains or does not contain a certain choice, or that a certain choice is actively selected? So basically, anything that a human being could do in a browser, whether it is asking a question about the page or doing something that changes the page, if a human being can do it, Capybara can probably express it. So anything that you can imagine you manually doing a test for your app, you can use Capybara and Cucumber to create an automatic version of that same thing. And that's the way that you think about this high-level sort of testing. So what's the anatomy of a step definition? It begins with a keyword, although like we said, given, when, then, they're all actually equivalent. And that's true in the step definition files as well as in the Cucumber file. But again, we try to use the one that most closely matches the intention. So if the step definition is usually used to set up preconditions, probably it makes the most sense to call it a given, but that doesn't prevent us from using it as a then step or a when step. The first argument after given, when, or then is a regular expression. That's the thing that Cucumber is going to try to match the step against. It will look at all the step definitions it knows, and by the way, it is an error for more than one of them to match. So it'll find exactly one step definition where that regex will match, maybe including capturing some of the arguments. Those captured arguments, if any, become arguments to the block, and the block can do anything it wants. But typically, things that it will do include making calls through Capybara or into your Rails app to make stuff happen. Why would a step fail? And we'll do a little live example of a step def in a moment here. There's two different ways a step can fail. There's kind of a good way it can fail and a bad way it can fail. The good way it can fail, if you can take my meaning for this, is there's a type of step, typically when you're writing a then step, which is checking post conditions, like the last one where it said, then I should see the name of the movie on the home page. The way that we write those steps includes having assertions in the body of the step def. An assertion is basically declaring your expectation that something is the case, and if that thing is not the case, and then we say that the assertion has failed, and that causes the test to fail. Now I say that that's a good failure because it indicates that your code is doing something, it's just not doing the right thing. The other way a test can fail is that there's an actual exception, like your app blew up. So if the user enters, blank for the movie title, and your test forgets to check that blank is not a valid value, that would be the first kind of failure. But if the user enters blank for a movie title, and as a result, because you have no error checking in your app, the app actually throws an error trying to enter a blank movie in the database, that's kind of a bad kind of error. That's like a type 2 failure. Your app not only didn't do the right thing, it didn't do anything defensible, like not sensibly. Okay? So there's at least two ways that a test can fail. So we had been doing little demonstration scenarios with Cucumber, which lets you write out these nice stories that, given, when, and then. And we saw that Cucumber kind of makes use of this library called Capybara that you can think of as it pretends to be a browser. In fact, it has all the logic built into it that a browser has, including how to do JavaScript. It just doesn't give you a visual indication like a browser of what it's doing. But it's manipulating all of the same data structures internally. So Cucumber's job is to match steps and step definitions. We saw how regular expressions are used to put those together. Capybara is what we call a headless client or a headless browser. It can parse HTML pages. It can initiate interactions with those pages. So in every respect, from the application's point of view, it looks like a real client. In our setup, the way it works is that there's an adapter called racktest, which allows Capybara to interact directly with the rack app server running on your computer. So everything in this stack here is one process. And this will become important for reasons that I'll show you in just a moment. But within one single process, you're running your Rails app against the test database. In front of your Rails app is the rack app server, as always. And then driving interactions through the rack app server is Capybara, possibly driven by Cucumber. When we start talking about other kinds of testing, we're going to add RSpec, which we're going to use for writing unit and module tests. And the reason that I pointed out that all of this is occurring in the same process is there's another scenario that you can use to test a staging app where they're in different processes. This is a scenario where you still use, for example, RSpec or Cucumber with Capybara to stimulate the browser. But now you actually are using a different piece of software that fires up an actual real live web browser. And you can actually see it doing all of the things. And that web browser can interact with a remote site. In fact, it can interact, for example, with a site that's deployed in a staging environment. So this is kind of an additional level of testing that is not quite production, but goes pretty far beyond what you would do on your own computer. Right? So this is kind of our world of testing stacks. And like I said, this is the stack that we've been demoing so far, where everything along the red line is running in a single process, where we've got steps, we've got a library that interacts with the app server, and we've got the real life copy of the app running against your test database. Okay, so that's the orientation of where we are. And we reviewed sort of what are the main moving parts, the skills that come with writing Cucumber scenarios. The first one is the steps and step definitions, right? So steps are the sort of stylized language in your file of what's going on, given when and then. Step definitions are the actual code that makes each of the steps happen. So we saw an example for something like, given a certain movie exists in the database, the step definition that implements that would probably do something like use an active record create call to make that movie exist, right? So making, basically, the step definitions make the test step do what it says it's going to do. We saw some simple examples, and I'll show some more today, of how to identify and interact with the different controls on a page. That's Capybara's job. One big trick that we'll see is using CSS to find and name elements. So for example, on a typical complicated page with lots of buttons, lots of different divs, a very useful trick is when you're creating that page, give IDs to the elements that you're going to want to use in your tests. Because if you've got a table of movies and every single movie has a delete button next to it, and you need to write a test that says when I click the delete button for a certain movie, then that movie should be deleted, wouldn't it be nice if the element you want to identify in your test has some unique way of naming it? So I'll show you some examples of that as we walk through. My hope is we'll walk through a couple of real scenarios from a real app, and you can see how they look. And then finally, checking the output, the post conditions. The most common type of post condition in a Cucumber scenario is going to be either something that looks at the page, because from the user's point of view, when a certain set of interactions happens, their window into the app is what is being displayed in the browser. And you can also have expectations that look directly at the database. So a good system level test might actually do both things, right? It'll check that the page says movie whatever was successfully created, but it might be wise to also look in the database and make sure that that's really the truth. Because you can imagine a type of bug where the movie didn't get created for some reason, but the message still gets printed out. In a real application where the scenarios are maybe a little more complex than what we just saw, and a few different features of Cucumber that let you deal with those. So here's an example of a real Cucumber scenario from a real app. This particular app has about 150 scenarios scattered across like 40 or 50 different files, which is sort of typical for a medium-sized app. Let me show you the actual app that this scenario is written for, and then we'll walk through the scenario steps. We'll look at the step definitions, and you can get a sense of how some integration testing issues are addressed in real life. So this is the staging version of the app in question, if it loads. And by staging, I just mean that it runs in the same kind of conditions and environment as the, let's see. There we go. It runs in the same environment as the production version, but it uses fake data and it uses a whole separate database. So the feature here is someone who's like a manager in a theater updating profile information about one of their customers. I'm going to pick a random person. By the way, all of the names and addresses in this thing are fake. There's a great gem that generates fake names, addresses, and emails and things for you so that you have realistic looking data. And you can see that if I go into this sort of editing screen, the customer can update things about their profile. There's also these things that are sort of shaded in yellow. These are things that only managers and administrators see. The customer doesn't see them themselves. And what I'm testing here is the ability to change staff-only comments, labels, blacklists, and other things like that. So you can see some of the basic steps that, given I'm logged in as Box Office Manager, that's important because that's the only way that I, as a logged in person, can make changes to someone else's profile, right? So a precondition for anything to happen here is I have to be logged in as someone with privileges, and I have visited the edit contact info page for a particular customer. So what happens, and by the way, why are these steps called background? You can see that this file has two different scenarios, change staff only comment, blah, 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 and changing customer's role. The background steps are preconditions that apply to all of them. So when Cucumber runs these, it will execute all of the background steps before each of the scenarios, right? So it's a way of pulling common preconditions out that apply to multiple related scenarios. So how are these things actually implemented? If we look at, first of all, let's run it and make sure it passes. It should, because I haven't, there we go. Sorry, I got to make the window a little smaller so you can see everything. OK, so if I just run this single file of stuff, this is going to result in two scenarios being run. OK, so there's the title of the file. And green is good, right? Sorry, my windows aren't wide enough to make this work really well. So here's the two background steps. And you'll notice that for each one, it is kind enough to print out which step definition actually matched that regular expression. So when I go to debug my tests, I can actually see what they matched. So let's take a look at what a couple of these might do. When I visit, let's take a look at the login steps. Okay, so there's a lot to unpack here, and as usual, the goal for you is not to understand every line of code. It's to sort of try to understand the high-level floor plan that I'm trying to explain what's going on. So how do you make true the step definition of given I'm logged in as a box office manager? What's the sort of implied precondition to that? Like to say, a box office manager is a kind of user, so clearly that kind of user has to exist. Because if they don't exist, you can't log in as them. So actually what the first thing the step definition tries to do is it uses what's called a factory, which we're going to talk about next week after the midterm, to immediately create a customer, a patron record, that has the privileges of a box office manager. Once that customer has been created, and the way that logic works is it creates them with a fixed password because this is a test, so we don't care. And it finally calls this little helper called verify successful login, which actually is basically a script. It goes to the logout page to make sure that there isn't like a residual somebody previously logged in. Then it goes to the login page. Then it fills in the email and password fields, and it clicks the button. So in this case, it's actually doing the exact thing that a real user would do. The only difference is before trying to log in that user, it had to create them. Why? Because the test database starts out clean with absolutely nothing in it. So every piece of information you need for a particular test has to be created somewhere along the way for that test, and then it gets incinerated after the test is done. As you might expect, there are a lot of shortcuts so that you don't have a tremendous amount of code in every single test, but this is the general flow. Okay, so that kind of takes care of the first one. I've created someone who's a box office manager through a create method that I haven't talked about, but trust me, it works. And then I've actually gone through the literal steps through the web user interface to make that person log in. And then the next step says, I visit the edit contact info page for a particular customer, myself. So again, what is being implied in that line? It says, I visit the edit contact info page for customer Armando Fox. That assumes that there's a user named Armando Fox. Otherwise, there's no way to get that step to work. So you can see where I'm going with this, right? Something about that step definition is probably going to say, if there isn't already a customer named Armando Fox, then please create him. By the way, why might there be a customer named Armando Fox in the test database, given that I just told you the test database always starts out being empty? Why would the step definition for something like that second step be able to check whether maybe the customer already exists? How might the customer already exist in this case? Sir?
Don't we see the database?
So one possibility is that you seed the database beforehand, but suppose you hadn't even seeded the database. Why might it be the case that sometimes in a step def like that, the named customer might already exist?
You might have had it before.
I might have had a previous step that created him, right? So, or another way to look at it is further down here, like let's skip down to this step. After a bunch of things are done, then customer Armando Fox should have the following attributes. When this step definition runs, the customer named Armando Fox will already exist because he was created up there. So some of these step definitions have to be written in such a way that if the customer exists, great. If the customer doesn't exist, then just create one that has the required name and get on with your life. Right? So we'll see a mechanism called factories that makes this really easy to do. Basically, it says, look, all I care about is that the customer have that name. I don't care about the customer's other attributes. Just make one and just make it be a legal person. The only thing I care about is that the name matches. Right? So there's software that will let you do that. Yes?
So going back to the
Given? Yes.
box office manager, the step definition like goes through the steps of logging someone in. So then isn't it reliant on the login part working? Like even though in this case it's a precondition, so it shouldn't.
Yeah, that's a really good point. So the question is, given that my implementation of step definitions for logging in actually are using the real flow and visiting the real pages, that implies that if that part of the logic in my app is not working, then any scenario that tries to do login this way will also fail, and that is absolutely right. And there is kind of a chicken and egg problem here, because sometimes before you can write a test, you have to have a minimal amount of stuff working so that you could even write the test, and that's exactly what you're observing here. Now, the real reason, and I'm going to make a confession here, I'm going to go public and say this, is that this scenario was written, and don't kill me, it was written after the code to implement login had already been done. Now, my only defense for this is that I was young, it was many years ago, I was under the influence of substances, whatever. I wrote the login and logout code, and I sort of tested it the bad old way, which is like by typing in a web browser, like, oh yeah, seems to work. And once it seemed to work, I was like, great, now I can use it in all of my scenarios. Don't do what I did. Okay, it was 2008, it was a crazy time. The revolution was brewing, and I probably just, I didn't know what I was doing. I would do it differently today. But yes, well observed, that in this case, I'm relying on the app logic to actually do this. Okay, I'll do like a few more. We don't have to walk through the whole scenario, but I want to give you a sense of, oops, where'd the scenario go? What's going on here? When I interact with a bunch of stuff on the page, and as a reminder, here is what that page looks like. So there's a bunch of things I can fill out, like email, address, et cetera, et cetera. I can select the birthday here. But basically, once I have done these things, notice that I've identified myself as a lush. I don't know what I was thinking when I wrote this scenario, but whatever. The post condition says, then I should have the following attributes. And there's like this nice little table thing. So a long way to do this would have been, you could have a bunch of steps of the form. Then Armando Fox should have the comments attribute equals lush, and Armando Fox should have the blacklist equals true, and customer Armando Fox should have blacklist equals true. But that will be extremely boring to read, and it gets us farther away from what is trying to be tested. So in this case, I had the good taste to use what's called a cucumber table. Basically, let's go to the step definition that does that, and cucumber is telling us that that's at customer steps RB 104. Okay, so what am I actually trying to do here? In my somewhat convoluted step definition, the first thing I'm doing is I'm capturing the first and last name of the customer. Find customer is a shortcut method that I wrote that will actually find this person, and hopefully it will. And then basically, using a syntax which you do not need to understand in detail here, but I want to show you how it works generally, I'm essentially walking through the table. What I'm getting back is a bunch of hashes where each hash is a row of the table. Let me make it so you can see the rows again. Okay? So you can see that the table columns are called attribute and value. And basically all I'm doing is for each attribute and each value, I'm just checking that the appropriate attribute of the customer, don't worry about the typecast stuff, equals the name of that attribute. So the important thing in this example is not this code, which is a little bit tricky. It's the idea that you can tablify certain kinds of information. That gives you a shortcut of expressing, I have a bunch of values and a bunch of keys, and I just want to make sure, I want to kind of do a mass check on all of those. I'll show you a slightly nicer example that doesn't rely on some of this weird. I had to sort of work around something Rails does here, so don't worry too much about that. Let me try to show you one other example of a cucumber scenario. Tabular data, that's a good one. Let's see. Is that one? No. There we go. OK. So again, I want to give you a few highlights of a more complex scenario, not so that you understand every line, but to give you a sense of what these things look like in real life. Here's a scenario for refunding an order. So someone has ordered something, and for whatever reason, they want a partial refund of it. So I've got a couple of different scenarios here. And you can see that I basically have one scenario that refunds the whole order. I've got a different scenario that only refunds certain parts of the order, and the scenarios are checking different things. But of course, in order for testing refunding an order, you first have to have an order. And if you have an order, that means that you have a person who made that order. So you start to sort of see how your preconditions have to get set up, right? And indeed, my background is basically a bunch of steps that ensure that there's a customer and the customer is placed in order. Because we got to be specific, we got to pick a name of a customer. It looked like I chose to pick tomfoolery this time around. And I have a step that basically has another example of one of these tables. So the step definition for this is, you can imagine, is going to march through that table and do some amount of work to make it be the case that Tom gets all those items added to their shopping cart, and Tom eventually purchases that order. And now you can imagine, as you're starting to write this, you think, OK, well, gee, if Tom is going to add tickets to see Chicago on that date at that time, then the assumption is, what are the assumptions? What assumptions does this given step with its table make? What's going to have to be done somewhere in the test code? What has to exist in order for this step definition to even be a thing? Yes?
The show?
So the show, so it implies that there's a show set up in the system called Chicago, that it has a performance at that particular time, that date. It also implies that there's a guy named Tomfoolery, and that he has managed to buy tickets to all these things. And then look at the very next step. I'm logged in as box office manager. So that's an assumption. There has to be a box office manager, and they have to log in. We already saw how that's done. And finally, once all that background is set up, there's a page where the box office manager can see all the orders for that person. In fact, I can show you what that page looks like so you can tie the test to reality. Here's an example of that page for some fake customer in our staging database. Orders. Okay, so this is an example of the kind of screen that only the box office manager sees, and you get the idea of how the interface works, right? Like if I check some items and I click cancel checked items, then they get a refund, et cetera. But this is the user interfacey version of what this is trying to test, right? So, and then the last thing I want to call your attention to is things like stub successful refund, stub successful credit card payment. Again, when we talk about the details of how you write these tests, we're going to go into how those work. But what's going on here is that if you were using the real live site, the act of paying for an order involves doing a credit card transaction, because that's how you pay for things online, right? And in the real site, I don't know if you guys have heard about Stripe, which is basically an API for credit card payments. The real site makes a call out to Stripe to say, please charge this person this many dollars. Obviously, when you're running tests, you don't want to be calling Stripe and trying to do credit card payments. Even though Stripe has an excellent API for testing where you can provide like fake credit card numbers, you don't want to be hitting the Stripe server every single time you run the test, because you could be running it hundreds of times during development. So there's basically some separate logic in another file that says, for these tests, when the call to Stripe happens, just cut it off. Return a fake value from the call as if Stripe said that it was successful. Because that's not what the test is about. We just need to make that behavior predictable in a testing environment. Okay? So what I'm trying to do here is kind of give you a grand tour of what these features look like in real life. It's not too much of an exaggeration to say that if you can do something manually in an app that has a web interface, then you can automate that thing in one or more tests using this kind of setup. And yes, you're going to find that sometimes it feels like you're spending more time trying to get the test to work correctly than trying to write the code. It's going to feel like that. Trust me, because every time I sit down to do more work, I often feel like, gosh, I wrote the code. I know the code works. Why is it taking me a long time to get the test to do the right thing? What you forget is how valuable the tests are, because once you've written it, you have it forever. And every time you make a change to anything in your code base, you can run all of your tests and ask yourself, did I break anything? And it's really, really nice to know that at least as far as the tests that you have created, you haven't broken anything. So yes, it takes a long time sometimes. Sometimes it feels like it takes too long to get the tests to work the way they're supposed to, even when you know the code works the way it's supposed to. But the reason to do it is now you always have the test, and it's permanently part of your test suite. It's documented. So in fact, if I forget how refunds are supposed to work, I can actually just read the scenario, and I can remind myself what the user interface is like, right? I can use this to even explain to a new box office person how they should do it. So have some faith, hang in there. The very first few scenarios that you write with Cucumber are going to seem very painful, but hang in there because it gets easier fast. In particular, as you write more scenarios, you start to develop more and more steps in your sort of step definition vocabulary, and you end up needing to write less and less new code per test. You end up reusing some of the step defs you already had. Okay, so stick with it. It's going to feel weird. I know it's like it hurts when I do this, but if you do it enough, your arm will stretch out, and then you'll get good at it. Okay, so that's a high-level tour. There's a lot of machinery here that you haven't seen yet. We will sort of get into it as we talk more and more about how to write these kinds of tests. But I wanted to give you a sense of what the scope of these things is like. And I hope that I've done that to some extent. So a few pitfalls when you're writing these Cucumber scenarios. We saw that there's the difference between a happy path and a sad path. The happy path is sort of when the customer or the client or the user does everything right. They do everything the way you expect, and the software behaves the way you expect. But that's usually not enough to say that the story is done. The way that your software reacts when something goes wrong is equally important. So covering the sad path in your test is usually part of marking the story finished. Also, be careful when, sometimes it's appropriate in some of these tests. We saw examples of when such and such a thing happens, then I should not see something on the page. And usually when you write that, your intention, for example, here's an example of, the user deleted the movie called Emma, and you might say that when they revisit the list of movies, they should not see Emma on that page. Makes sense, but remember that if your app gives an error or visits the wrong page or does something completely unexpected, that step will still pass, right? So be very careful with negative expectations. They only tell you what you don't expect to happen, but there's many, many ways that your app can make a mistake, and usually only one way that it can be right. So if you're doing stuff like this, make sure you're also including positive expectations or positive assertions to check the results in the database, to check whether there are other things on the page that at least will give you a signal that it's the correct page, right? Like if it's really the list of movies page, okay, maybe you should not see this movie, but there are other movies that should still be there. So including those positive expectations sets some additional confidence that your test actually is testing the thing that you think it's testing. On the other hand, you also have to be careful, even with positive expectations, because especially if you see something like, then I should see some string, and there's some situation in which that string might appear multiple times on the same page. For example, this is sort of contrived, but using a word like and or the, then I should see the word and. Well, the word and probably occurs a million times. So if you're not careful about how you phrase these, sometimes the test might pass, even if, in fact, the functionality is not correct. One of the examples, which ironically we used in the exam code, is that there's a helper in Capybara called within that lets you restrict searching for a particular element or text on the page to be within some CSS selector. So when we talked very briefly about HTML, we remembered that there's HTML elements and there's also containers like divs and spans. A very common testing technique, in fact, one that I use all the time, is when I'm designing my pages, my views, and the pages are sort of made up of different sections, I make sure to give each section a unique ID in HTML just so that I can name it in a test later on. So for example, if I have a part of the page that's where the shopping cart is shown, I'll just give that the ID shopping cart, because now in a test, I can refer to it specifically and I can narrow down expectations to only examine that part of the page. Right? So again, it's really about making sure that when you implement the test, they're testing the things that you think they are. So my hope is that a lot of you are getting to the point in the project where you are finding it necessary to write some scenarios that are sort of non-trivially complex. You've probably figured this out, but Capybara can do a lot of stuff. But it's a pretty complex power tool. And a really good way to get a sense of what it does is to look at if you're inheriting a legacy code base, look at the step definitions and the Cucumber scenarios that are already there to give you a sense of what's possible. But here's a few sort of generic power user tips that you may find useful as you're trying to develop your scenarios. Seeing what Capybara sees. So sometimes you'll write your scenario saying, fill in this with that, and then I should be on some page, or I should see something on some page, and it'll just fail. And what you want to know is, OK, well, I said I should see X. If you didn't see X, can you tell me what you did see so that you could figure out where the bug is? There's a gem called Launchy, which I think might actually be included by default in the gem file if you create a new project. I'm actually not 100% sure. But if it's not, you can certainly add it. And don't put it in the production group, just put it in the test and development groups. If you include that gem, it adds a new method in Capybara's namespace called save and open page, which is super, super cool. Because if you call save and open page, it will save a static HTML representation of the page and pop up a browser window. And then you can see the page that Capybara was seeing at the moment that you called save and open page. You also get, with the standard websteps.rb that is one of the gems that we sort of recommend that you seed all new projects with. It defines a step definition called then show me the page. And the only thing that step definition does is it calls save and open page. So if you're developing a scenario and you can't figure out why the scenario is not working the way you expect, and all you're getting is the error message from Capybara that your assertion failed, use the Launchy gem and actually see what Capybara is seeing. And then you can view source. I mean, you could do everything that you could do if the page was live in the browser, because it does, in fact, open up in a browser. A really, really common reason that things like this happen is, for example, if you get to the point in your app where now you're about to add the idea of logging in, now all of a sudden you might have some scenarios that don't work anymore because they now require, or they assume that the user's logged in before they can get to that point. So all of a sudden you had scenarios that were working, and now you have to add some, instead of getting to the page you thought you were going to get to, what you're actually getting to is a page that says, sorry, you have to be logged in, or something like that. So the Launchy gem is your friend for things like this. In order for it to work, though, you have to be doing development on your local computer. So if you happen to be doing Cloud9 IDE-based development, I don't believe they've gotten this to work in Cloud9 yet, for reasons that have to do with how they implement app serving. But I can't survive without then show me the page. If you Google the obvious terms, cheat sheet with Capybara or RSpec Rails, there's a zillion cheat sheets out there. But what they boil down to is that the magic object in Capybara is this thing called page. Page is a method that's defined everywhere in all your step definitions, and what it returns is a representation of basically a top-level HTML element that supports these really great things like find. Like you can say, find me the page element or elements whose CSS descriptor is this. So this would be an element whose ID is some div. If you know how to use XPath, XPath is this much more complicated XML representation for navigating the elements of an HTML page that lets you burrow down and say, look for an H1, and then inside the H1 look for a paragraph, and inside the paragraph look for a tag that has these attributes. The syntax is a little bit hairy, but XPath can find anything. Now, as I think I mentioned early on, a really good habit to get into when you're designing your HTML views is if you think that some part of that view is going to be useful in a scenario for testing, give it an ID or a class that is easy to find. So if there's a page that somewhere on the page there might be a place where an error message is displayed, and if you're going to write a Cucumber scenario that is going to look for, does the error message have the right text, give the error messages div some obvious ID, and then you can just say in your Cucumber scenario, tell Capybara, find the element whose CSS matches that, and then you're done. Okay, but if you haven't done that, or if you're dealing with legacy code that hasn't done that, XPath is a fallback. So how can you use these? You could say, expect the page to have a CSS element matching something. So for example, going back to my, if you're showing an error message, the error message presumably should only be there if the error condition occurred. So you might have a scenario that's really just checking when the error condition is stimulated, does the box containing the error message actually show up on the page? You could use something like this. In general, I know that in the early examples we had this stuffed up, then I should see, quote, some string on the page. As we mentioned earlier, it is really easy for that to give you false positives, because all it's doing is checking whether the string occurs anywhere on the page. It's not constraining it to, is it within a certain part of the page, or does it occur more than one time? So there's a reason that the gem that provides these things is called Cucumber Rails training wheels. The training wheels should come off as soon as possible, right? And you should find yourself writing step definitions that are much more precise in what they're actually looking for. So this is one way to do that. There's also, you can do a little bit of Googling about this as well, but you may have noticed that if you have pages where you're using the default Rails form helpers for things like doing dates, the date dropdown is actually 3 dropdowns, right? There's like a month, day, and year, and you'd like to be able to say something like, when I select, January 1st, 2010 as the whatever date, as opposed to saying, when I select January from month and 1 from day and 2010 from year. So there's a number of gems out there that basically add step definitions for Cucumber and methods in Capybara that make it more graceful to deal with stuff like that. In particular, if you find yourself using things like JavaScript libraries that do like those nice little date picker pop-ups that have multiple months, usually those will come with, or you can Google and find a separate gem that will let you say something like, when I choose whatever from the date pop-up, and it will do the right thing in Capybara, and you don't have to sort of go step by step for each of the subtasks. I think I mentioned that one of the projects is actually working on a code base that I own. Some parts of it I'm embarrassed by, and other parts I'm pretty proud of. But it does have hella Cucumber steps. So if you're looking for examples of doing things like dealing with tabular data, you got a table of data that shows up on a page, and you want to find out whether the table has a row containing some entry. There's a bunch of code that shows you how to do that. There's entries about passing state between steps, which is really useful. So for example, if I have a sequence of steps that is aimed at selecting a particular performance, in my later steps, I want to say things like, and I want to buy a ticket for that performance. It implies that somehow the step knows what I mean by that performance. So there's examples of scenarios where instance variables in the Cucumber step defs are used to pass state down, so you can make references like that. Time travel, super, super useful. If you have any features you're trying to test that where you're testing a behavior related to the time or the date, there is a gem called TimeCop that basically lets you fake the clock that is seen by your application. You can make it be a particular day. You can move forwards and backwards in time. And that lets you consistently write scenarios that will always be operating under known circumstances. So, if you've got something about leap years, you can first set the clock to, February 29th of a leap year, and then do whatever test you're supposed to do. Related to that is, again, you can see some examples of this in my own code base and somewhere else, but there are tags that you can apply to scenarios saying, only for these kinds of scenarios, set up some certain conditions. So for example, in my app, I have a number of scenarios that actually do depend on the date, because they make assertions about things expiring and stuff like that. And then I also have a lot of scenarios that have nothing to do with the date, so it doesn't matter. The ones that depend on the date have a tag, and related to that tag is a little piece of code in the env.rb file of Cucumber that says, when a scenario that has this tag is run, do these steps first. And in this case, the steps are, it uses timecop to set a date that is always the same for every scenario in which time matters. So if you've got scenarios that depend on something, right? Related to this is if you give the tag @JavaScript. Some of you may already have discovered this or been forced to discover it. Capybara actually has a JavaScript engine inside it. So if you've got JavaScripty features on your page, like when you click on a button, it reveals a pane or causes a dialog to pop up, you can test all that stuff. But turning on JavaScript for Capybara is very expensive in terms of performance. So if you tag a scenario with @JavaScript, it will fire up the JavaScript engine, and it will be ready to do any kind of testing related to those interactions. If you leave that tag off, then actually you'll get a static page. So if you have pages whose proper behavior depends on having JavaScript turned on, and we'll have a lot more to say about JavaScript in about 2 weeks, make sure you say @JavaScript in front of those scenarios, or they will fail to run. This is a few examples, but like I said, the best way to learn about what you can do with Cucumber and Capybara is find a code base where you can look at the step defs. The website that I'll put the link up again, but it's the website that has links to all the repos for all previous CS169 projects. The step definitions you'll find there are of varying quality, but you'll get a sense of what is possible.
Alright, so that's a long video for Cucumber. It's basically a 1-hour crash course for Cucumber. So for you guys to learn more about Cucumber, I think I mentioned already last week, but again, you can find more materials on this website. Cucumber, so you can find Cucumber here, which is the last row in the table. You can find this cheat sheet here, and then you can find more information on their website as well. So basically what we've talked about so far, Cucumber is basically a tool to kind of take your user story and scenarios and then convert it into something that's actually testable. Kind of turning that into a testing code, although you still need to write some of the meat of the test yourself. But it's a nice way to handle that. And then for Capybara, it's basically a headless browser, and I believe it actually can integrate with some handful of browsers. Basically, I think it can integrate with Selenium, and then Selenium can connect it to like a real browser, such as Chrome, Firefox, this kind of thing. And then it basically runs all these definitions in a browser. And by default, it's the headless one, but you can always use the actual browser for testing. And I actually did it once, I believe. And then the other time I actually used Capybara to do browser automation or sort of crawling. Because some stuff doesn't work in a headless browser, especially things like JavaScript, that kind of thing. But most of the time, Cucumber and Capybara goes hand in hand. because we're talking about the behavior testing, so we need the browser to actually go through that to make sure it's actually working. Right, so for Cucumber, I think we've got 2 more videos to finish. Yeah, I'll get to the next video.
Here's an imperative scenario, and the feature that I'm claiming to test is up top. It says movies should appear alphabetically, not necessarily in the order that they were added to the database. Pretty simple to understand. So if you kind of take the time to read this, and I hope you don't because it's super, super boring, but you will eventually figure out that it's going through that adding new movie workflow, once for a movie called Zorro, and once for a movie called Apocalypse Now, which should be sorted before it, but was actually added later in time. And then finally, when it gets back to the main page, it's checking that they appear in the correct order. The problem with this scenario, and by the way, this will work, right? If a human being did this, it's the same as the scenario doing it automatically. So there's nothing wrong with this from the standpoint of, is it actually testing the functionality? The problem is, from the point of view of being a good scenario, this is the only step in the whole thing that actually speaks to the behavior you want it to specify. Right? The whole point of behavior-driven design is that you're focusing the tests and your interaction with the customer and everything, not on the implementation, but on the behavior. All of this stuff in here is about implementation. It is very, very specific about the way that movies get added, even though the way movies get added is irrelevant to this test. This test only cares about, no matter which order they're added in, they appear in the correctly sorted order. So how could you do better than this? As you develop your apps, you'll find that the domain of your app can sort of form its own little mini language. So if your app is about movies and ratings, then things like movies and ratings become what appear in your Cucumber steps, as opposed to the step-by-step process of how you add a movie or how you specify a rating. Imagine a much more concise version of that scenario I just showed you that looks like this. Given I add Zorro with this rating and I add Apocalypse Now with that rating, then I should see one before the other on the home page. This is a scenario that really focuses on the thing I'm trying to test. So the question is, how do I get from one to the other? There are a number of strategies for doing it, but I will point out 2 key things. One of them is nothing here says about forms and filling out and the names of fields. It just assumes that somewhere there is a step definition that says, given I add Zorro with a certain rating. There's at least 2 ways I can think of to implement that given step. One way is you do some active record calls directly that create a movie named Zorro and cram it into the test database. You do the same for Apocalypse Now. You're good to go. A different way that you could do it is you could be a purist. And you could say, OK, I'm going to make it so that even these 2 steps of the test, even though they're not central to the test, I would like them to only exercise the app exactly how a user would. A real user cannot just put something in the database. They would have to fill out a form. So how can we make the test actually do that without having the verbal diarrhea of the previous slide? Here is a way to do it. You can basically use existing steps as a subroutine. So I could define a meta step, if you will, that says, given I add a movie with rating whatever, and the entire body of the step def is just do these steps. It'll take a little bit longer to run, but not longer enough that you would ever notice. And it will have the same effect as the very long scenario before, but now the main scenario has eliminated all of the cruft that really has very little to do with the test. And as a developer, when you go back and look at that scenario in a few weeks, it'll be much easier to remind yourself of what precisely you were trying to test. What about that other step about I should see something before something else? Well, here's where a little bit of regular expression hackery can come your way. If I have the entire page, I can say, well, I'm going to construct a regular expression that contains string 1 and string 2 separated by any number of any kind of character. If the page matches that regular expression, then it's safe to say that string 1 comes before string 2, assuming that each of those strings doesn't appear more than one time on the page. So there's a number of ways that you can sort of do trickery about before and after. But the important thing is you want the steps in the Cucumber scenario to read like they have something to do with the app, not like they have something to do with web forms. those basic steps, like when I fill in this, when I click this button, when I click this link, those kind of come with Cucumber, but they're really training wheels. They're a starting point, and I will send out an email where you can see that file, and the comment at the very top of the file says, TLDR, you should delete this file, because your scenario should not be full of when I click this and I fill in that. They should have statements like when I add a movie that speak to the domain of the app, not the specific elements on the page.
So that's a bit more about Cucumber, how to try the testing code, that sort of thing. And we will get to the last one.
This is the planted document perspective. So partly the reason that we're doing this is in the past when we taught the class, and we get lots of nice comments about the class, and changed my life, and I got a job, and it's a wonderful intern. But there were people say, oh, I've done internships before. Nobody builds software with it. In the real world, they don't do it that way, right? And even on the MOOC, there were comments like, I would never use software built with Agile. This is crazy. This is the other way to do it. So what we thought, we'd let you know what the official alternative units looks like, because if you become software engineers, you may do projects like this, and you need to know what these things are. Also, it'll help you see where Agile came from and appreciate what it's doing. So this will take a little bit of while to be able to do this. So they don't use user stories, points, or velocity. What do they do instead? And it's pre-Agile. And how do you make these costs? And how do you make these schedules? So these are all the steps. If you get to be the program manager, you're going to do requirements elicitation, requirements documentation, the cost estimate. You're going to be doing the scheduling and monitoring the progress of the project. You're going to do change management, kind of like version control, for your schedule, the cost, and the requirements document. You have to ensure that the implementation actually matches the features that were kind of in the contract, right, in the documentation. And then increase the chances that you'll hit the schedule, hit the target and the budget. You do risk analysis and risk management. So these are all your tasks to do. This will take a little while to go over. So let's do the requirements elicitation. So you're looking for both what are called functional and non-functional requirements. So functional is like we've seen, right? Add a movie to rotten databases. Non-functional would be, it's a kind of a weird word, but it's like about its performance. Non-functional, it's not features, it should be non-feature, right? Non-functional means 99% response time, less than a second, or 4 nines of dependability. So how do you elicit those things? Again, that has to come from the customer, and so it's pretty much the project manager primarily doing this. Project manager tries interviewing. You want to find out how the work is really done, not the way it's supposed to be done. Maybe you send a questionnaire to all the stakeholders to have them fill them out, or you just have these informal discussions. But you're trying to fill out how should this really be done, or how is it done today. You work with the customer, create these scenarios. You start off with the initial state. You show the flow for happy and sad paths, what can be done concurrently in the final state. Third approach is what's called use cases. And there's actually there's a language called the Unified Modeling Language that helps you describe these use cases where you have little stick figures and showing all the steps from the user and the system to achieve the goal. So these are ways for the product, user requirements elicitation. What does the customer want? After you've elicited the requirements, you do documentation, and this is serious documentation. It's called the SRS in the lingo, that stands for the Software Requirements Specification. These are big, hundreds of pages. There is even an IEEE standard on how to write an SRS. So you get a document that describes a standard about how to build this document. And remember, this is inspired by software doesn't work. We got to make it like civil engineering. Civil engineering has a lot of documents. We're going to have a lot of documents, right? And then, so how do you figure out if the SRS is okay? And I'll tell you the 4 things to look at. Well, the way you do it, get the customers to read these hundreds of pages and give you feedback, or you build a prototype that has some of the features to give you feedback, or you generate the test cases to test the SRS. And so what are you looking for here? 4 things. The validity, are all the requirements necessary? Consistency, that's pretty bad if the requirements conflict. Sounds like it'll be hard to be successful. Completeness, is everything there? And all the constraints included? And finally, can it be implemented, right? So you're building this kind of book about the project before you build the project. So that's requirements documentation. How about the cost estimation? So what the manager does is decompose these, the software requirement specification into tasks. You want, bind it a little bit like, points for user stories. You want to bound the task between 1 and 8 weeks. If it's more than 8 weeks, that's too big a task. Less than 1 week is kind of hard to schedule. So your manager is looking at the task, breaking up these pieces, then given the task estimates, you convert that into dollars via salaries and overhead. That's pretty straightforward. And then when do you do this? Well, you do it before you get the contract and then after you get the contract, right? So you sure like those cost estimates to be similar, what I bid to get it and what it's going to cost the company to build it. So one idea is you add a safety margin. You and maybe you and your team work through how many weeks it's going to take to do these tasks, and you multiply by a number like 1.3 or 1.5. Another idea is you make 3 estimates. You make the best case estimate, the expected case, and the worst case. And then after you look at all those estimates, then you make your best guess. All right? That's the cost model that goes ahead. And now there's 2 kind of approaches to how to do that. One's called experiential, which is basically based on the program manager's experience and maybe the company's experience. This is what our guess is, how many weeks it'll take to do all these tasks. But they were trying to make software engineering like civil engineering again, so they came up with quantitative approaches. The first approach was simply, let's estimate the lines of code of each of these tasks, calculate for the company the lines of code per person month, and you divide them and you'll get how many person months it's going to take. Well, the problem with that is lines of code, Bill Gates has a code about lines of code being the wrong way to measure this stuff, so that didn't work very well. So the researchers decided we're going to measure a bunch of projects, we're going to come with a better quantitative model, and they call it the COCOMO model, constructive cost model. And it's got 2 factors and an exponent, and so they looked at a bunch of projects, and I hear this is the 3 significant digits, right? I think the average is going to be 2.94 to the times the code size and lines of code to this 1.23 penalty with a product factor of 1.07, right? You multiply that together, that'll tell you how much effort it is, put that in the cost budget. So the guys who came up with COCOMO, so that didn't work very well, so they came up with COCOMO 2, and it had 17 factors, right? So the software is getting more sophisticated over time, and they're trying we can make this quantitative, I know, if we just try hard enough. So not surprisingly, the survey says 92% of the time, the customer just relies on their experience to make this model. Okay, that's the cost estimation. What about scheduling? So what you're trying to figure out is what tasks you can do in parallel. And you may have heard of PERT charts. So let me show you what a PERT chart is. It was it was developed in the aerospace industry to figure out how long it would take, or in the space, how long it would take to build a space shuttle. So each of these nodes are milestones. So these little rectangles, there's 11 milestones for the project. All right, and then these names that are on these arcs say what's being done. So this is requirements elicitation. And then what these little numbers are on the arcs are how much effort it is, say person weeks, for example. And then the arrowheads indicate dependencies. So one reason that people made PERT charts is to figure out what's called the critical path, is given all these arrowheads, what's the longest, or the shortest time, no, the longest time through this effort till we get to the final milestone. And in this example, here's the critical path. So you just divide up all the efforts along those lines that tell you, and then some kind of productivity factor, and tell you how long it would take to do the project. And it could show you what things you can do in parallel. So if you're the project manager, you did the SRS, you break it into tasks, you get it into costs, and then you use those to create the schedule using something like PERT charts. Now that you've made a PERT chart, what do you do while the project's going? Well, now you want to compare what you predicted to how long things are taking, and so you track both the actual expenditures and the time for those tasks, maybe against your PERT chart. And what they found is that by sharing these intermediate milestones, there were 11 milestones on the slide, everybody is aware of whether you're on budget or on schedule or not, both the people building it and the customers. Okay, so this is, can you build it in time, and on budget? But you're not done as project manager. Does it actually do what you want, what the customer asked for? And this is called requirements traceability. So there's tools that are developed to try and tie in all these pieces together. The software requirement spec, what piece of the software requirement spec is associated with the piece of code that implements it, which is associated with the tests that validate that. So by having these tools to keep those together, you can ask yourself, well, did we really implement everything the customer asked? Well, let me go in and test. Is it passing that test? Well, good, because then it's handled that piece of the requirement. So are all the pieces of the 100-page document covered with tests and the corresponding code in the SRS? And then if the code changes, you want to go back and test that. Now, to try and increase your chances of hitting the target, there is borrowed from the business school, is risk analysis and management. So basically, you're trying to make this more accurate. So you're trying to guess what the risks are going to be before you do it. And so what do you do if you identify a risk? Well, you can do extra work to reduce the risk, do extra work to prepare yourself, or change your plan so that risk goes away. So a technical challenge, hey, the relational database won't scale to be big enough. Well, maybe we could find a bigger machine with a bigger relational database so we can make that risk go away. Boy, our organization isn't familiar with J2EE, which we have to use to build that. What can we do to mitigate that risk? We could send them to, we could take tutorials, online tutorials to get them better at J2EE so that risk is mitigated. Oh boy, the business risk is it's going to be too late for the market. Well, maybe we should cut back the features so we can get it in the market in time so that it'll be viable, right? Or you know, if it's really bad, then we shouldn't do this at all. So, boy, you can imagine, you're guessing the risks. So what's the advice you should do? Well, try and you guess what the risks are, make your best guess of the chances of this risk happening, and then on your own 10-point scale, give it an impact factor. Boy, if this thing happens, how bad it'll be for the project. And then you multiply the chance times the impact factor, and you come with a number, and you sort your risk by that, and then you tack the top 20%, and you're hoping that that's most of the risk. And so the risk analysis is trying to hit you on schedule. So these are all the things you need to do as a manager, and we put this side by side in the table, which you may be able to read. So here's the 7 steps on the left. So the requirements, documentation, elicitation, change management, schedule budget, ensuring requirements features, scheduling and monitoring, that's all that corresponds to user stories, points, and velocity, right? So user stories, points, velocity, which I just talked about in the last couple of segments, is, you know, relatively intuitive. Boy, this is what that replaces, right, for Agile. And then the cost estimation is this kind of loosey-goosey thing we talked about. Instead of trying to hit it and promising it, delivering features, and doing extensive risk management to make it more likely, well, you're saying you're doing it on a best effort approach. Okay, so that's what it means. That's the alternative universe here that many of you, a lot of people do use for lots of projects, and you may do yourself, that helps you to see what's different about Agile.
All right, we finished all the videos for today. Some closing remarks. So in the last video, again, Agile is great, but there's also problems, like the last point he mentioned. Agile is running based on an assumption that we do the best effort, right? But if it's a outsourcing project or a third-party partner that's developing your project, there's actually no way for you to tell are they putting the best effort. And also for certain contexts, best effort doesn't really make sense, especially for projects in our community, in our ministries. Sometimes we just have hard deadlines and we just have to make it happen. So in those scenarios, Agile also doesn't really work. And then also some other conditions that doesn't really fit Agile, or actually specifically for behavior-driven design. For example, for BDD or defining user story, it actually heavily depends on the client or the stakeholder. And then there are cases where stakeholder cannot be available to review or give feedback to user stories. Then in that case, creating a user story may not make sense. Also, sometimes for certain projects, you may just be the one-man team. You yourself may be both the programmer and the stakeholder or the product owner. in that case, you don't really need user story either, because one of the things that user story addresses is communication. It helps non-tech person to understand what a technical person is talking about. It kind of bridges the gap between the language boundary, kind of. But then if you're a one-man team, then it's actually not a problem. Then you may not need this tool to address it. And then last thing is we've talked about user stories, behavior-driven design, and the cucumber. And actually, these can be separate things. You can do user stories. You can build the user stories to help communicate with the clients, to understand the specs, or even to use that to define your tasks and then just assign it among the team members. But you may not actually necessarily need to do the test part or to really implement it into a Cucumber test that's actually running on like Cucumber, running like Capybara, the headless browser. So that's also something for a real project you may want to consider and decide. Like if you're really in a rush, but you still want to get some benefit from behavior-driven design, then what you might be able to do is use the user story technique to help you clarify the specifications, the desired behavior with the client or with the stakeholder to figure that part out, where just leave the testing parts behind, if you're in a rush. Again, that's my opinion. May not be the industry best practice as we've described described by the professors in the lectures in the videos. But again, like we have our own situations. Also, like the last video where that professor mentioned, like when you join a team, you join a company, you never know what their procedure looks like. Right? There's still plenty of companies that follows plan and document procedure, follows like waterfall, follows what they call it, the pivot version of waterfall. So you never know. So you still need to like kind of adapt to different procedures and understand the benefits, the reason why we do it different ways. And then when you have the chance to decide a process for a project, then by thinking about these, it can help you to get the most optimal procedure for you and for the project. Okay, so that's about it for today's content. And then for homework, let me log back in. So I haven't got the time to update the Populi lesson page for today yet. So I will, I think tonight I will do that and update the lesson page. But other than that, there's no additional homework for today. So if you haven't finished the homework last week, that was week 5. So you would be then going back and then finish that part. So it will be either a summary for chapter 7 or write the source code, do the coding for the hands-on practice for BDD and Cucumber. Okay, so since we just have 5 minutes left, we will just skip the practice session. So anyways, if you got any question when you try to write the Cucumber code, write the tests, feel free to contact me and I will try to answer your questions. But again, as I said, what we've talked about so far in this week or in this module for BDD, there's actually two separate things. There's the BDD, which, you know, the technique for building user stories, and then we also mentioned like lo-fi mockup, wireframe, that kind of thing, versus the coding part, the hands-on part, which is using Cucumber, Capybara, writing actual tests. So although the practice or the homework primarily focus on, you know, writing the test code, you could still like do some of the thinking process by yourself. You know, just think about some of the projects you might have worked on before, or for some of you may not have worked on any real project yet. You'll probably, I hope some of you would be taking some other courses, like the web course, then think about whatever you're doing, the homeworks you're doing for that course, and you know, you can try to come up with some user stories based on that application, and that's also some good practice for you to do, although it won't be scored or graded, or I won't ask you to submit it, but just keep in mind the homework just touches the testing part, but for coming up with user stories and all that, you could also, that's also something you can practice by yourself. Right, so we will just end our lecture today here. I'll see you next week. Bye.